Thank you very much for the introduction. Thank you to the organizers for inviting me here. My name is Enrique, and I'm going to talk about TensorFlow for mobile developers. How many people here has experience already with TensorFlow? Okay. So let's gonna do it other way. If you don't have experience with TensorFlow, please stand up. Stand up, please. If you don't have any. Okay, now let's gonna make it the other way around. If you're standing, sit. If you're sitting, stand. Yeah, just change. Okay, I like that because if there is not many people, they are a little bit shy. But if you force to make the other way around, everybody will stand and then you have to change. Okay, so I hope you can learn something about this framework today. Just very shortly, my name is Enrique. I'm a freelance Android developer, part of the Google Developer Expert Crew. This is my Twitter handle. I will post the slides there later. If you have any questions, you can at any time write me there. I try to be very active in the community as well. As maybe is obvious by my accent, I'm from Spain, but I live in Germany since many years. And well, first, I asked about TensorFlow. How many people has experience with machine learning? Now only stand in the hand, not. Okay. In production? Okay. I saw this tweet once, and it seems to be very clear for all of us that like to work a lot with new technologies and things that are relatively at the edge, and is that we try everything that is new, but then it's hard to put it on production sometimes, right? Like, this is very cool, but we don't find any business case that can actually bring money, and we can charge for it, or our company can implement it. There is also a lot of buzzwording about artificial intelligence. So what before it was called an algorithm, now we call it artificial intelligence. If everything is artificial intelligence, nothing is artificial intelligence. There is a lot of confusion on those topics. I read this excerpt here on a book called Superintelligence from, I don't remember the author. It was referred by Bill Gates and Elon Musk, and it says something like this. As soon as it works, no one's call it AI anymore. So if we don't understand it, it's AI. If we start understanding it, it's something different. I want to put here some classification for you before I start, so you can have a more clear idea of what each of those topics means. Artificial intelligence is the art of making machines smart, such as a self-driving car. I actually started getting into TensorFlow designing a self-driving car. As you know, self-driving cars have different sensors. They have cameras to identify objects. They also have a radar to find objects that can be on your position, or an echo. They also have a thermal camera to find maybe during the night a human that is standing and not moving, but you don't want to hit them. So I think it's a combination of all of them. Machine learning would be the art of building machines that actually can learn. You don't program them for all the possible inputs. They start learning by themselves. There can be more different types, like supervised learning or unsupervised learning. And neural networks is one of the different algorithms that we use in machine learning. Neural networks there are also different types, like convolutional, etc., but right now I think we can keep it simple. I saw this classification somewhere on Twitter. I don't remember exactly where. I found it very accurate as well. We have rule-based decision-making systems, like if this thing, then the other one, or a switch where we go through different conditions. So if you see this on any source code, please, that's not artificial intelligence. That's if-else condition. You can implement them in any language. We also have a statistical reasoning where we can do interpolation and extrapolation of data. Essentially, every programmer with no special training can perform those tasks. And then we have systems that are a little bit more specialized, machine learning and artificial intelligence. They require some more training. They have their own set of, well, it's not programming for machine learning and artificial intelligence is a tool, not the tool itself. This is the example we always see when it comes to neural networks and machine learning. We have the image of a dog, the image of a cat, and we try to see if it's a dog or a cat. It's very accurate, but it's very simplistic. With neural networks, we can do much more. Essentially, everything that is, can be serialized into ones and zeros, into data, can be fed to a neural network to train it. And we have some fantastic examples. We can train sound, or we can train neural networks with an input of sound, of text, of numbers, etc. Now, you're probably aware with some of the products here, right? They are, I think we all use them on a daily basis, very likely. Those are products from Google that are today using some machine learning behind them and some neural networking. In the case of Gmail, we have the smart reply. When we open an email, we can see like three, based on the context and based on the language, which is also surprising, we get three options that we can type them and send them. In YouTube, we have the video recommendations. Of course, the entire search has a lot of neural networking behind it. The assistant, you probably saw in the Google I/O this new thing from the assistant where you can make a reservation, and then there is a bot calling the restaurant, pretending to be a human. That's behind all those things, there is a lot of machine learning as well. Now, to see things that are not that complex and not that esoteric, this is a copy of my emulator in Android. You probably have Google Photos application. I use it a lot because it has free space. So normally you don't need to store anything on the phone. I just upload them in Google Photos, and they're stored there forever and ever, or until Google decides it's not free anymore, which can happen. It happens very often. So I like a lot Japan. I work from home, so I travel there like 3-4 months every year, and I take a lot of pictures, obviously. So Google Photos have this function where you can type any word, and it will find pictures that has a connection with that word in. And it's not based on the geolocation, or not exclusively. If you have the application, try to type things like green, tree, ocean, kids playing, whatever, and you will get the result. This is for the word Japan in my Google Photos. I select Japan, and I get a lot of pictures taken in Japan. And it's surprising because it gets things such as not the basic ones, like temples or toridor, but also like sushi, or things that are a little bit harder to classify, but the machine is very efficient. Now, I have mentioned the smart reply. So in the smart reply, when we select an email, we get a proposal of 3 answers that can fit within the context. According to Google, right now, this is 12% of all the responses on mobile. If we click here, a person is asking about a conference. The options I get, maybe went a little bit fast, is yes, I will attend, no, I will not be able to make it, or I will be there. If you get an email from a person asking you if you will celebrate whatever party, it will offer you, yes, I will be able, not, sorry, I can't, etc. It's very surprisingly accurate, and it gets better with time. Now, Google Translate. Google Translate is fantastic. It's especially if you're in these countries, like for me being here in Ukraine, it's not so easy because I don't understand Cyrillic. So sometimes people tell me, yeah, that's very easy. It's in Novzborovska Street. I don't know how to read Novzborovska, so I need to write it. I make a lot of mistakes. But Google Translate can help a lot here. This is an example in Chinese. So the wording in Chinese means whatever. That was, or let me explain before. Before Google Translate used the neural networks, had a phrase-based model translation system. It's a little bit more complex, but basically we generate a tree, and in the tree we start comparing word by word, sentence by sentence, sometimes using an intermediate language, and we make the translation. You can see that this is something you understand, but it's not accurate, whereas this one that is using the neural network system is exactly like it should be. This is a comparison of how effective the translations are. On blue, it's the phrase-based system. The neural network is green, and the human is yellow. As you can see from some languages, like French to Spanish are very similar languages, the neural network is almost as accurate as a human. And in general, the neural network is getting closer and closer to the human translation. Again, this improves every day. So at some point, likely, the neural networks will catch up with the human translation. Some languages are still not so accurate, like Chinese to Spanish or English to Chinese, because the distance between language, the difference in roots and structures they have is still hard and far away. But again, it's definitely a matter of time. I would like to show you a video on how Google Translate works. Try to focus a little bit on the speed as well, how fast this is actually translating. So you see that there are some words. As you're moving, it's painting it on every frame. It's fantastic that it keeps the color and the fonts. And it even changes the lines. Sometimes you have one line, two lines. And it's working on real time. So this is almost immediate. That's my favorite part of the presentation. Well, I like especially that this happens immediately, right? There is like no, you don't need to send it to a server, you don't need to get the response back, you don't need to send the image over an internet connection. And there are much more mobile cases for machine learning. If you have one of those devices, I use it a lot, for example, Google Hangout. If I'm walking and I get a message, I can just use this fast answer. Or if I'm riding the bike, which maybe is not so safe, but then I see a message, I can just click, slap, click, write to you later, tell you something. And those devices can make use of all the sensors they have, motion, GPS, etc. There are more use cases that are being done actually with TensorFlow. This heymaggie.com, it translates from baby into English. So what they did, when a baby is sad, they have like some pitch, some volume, some different type of tone. When they're hungry, they're sad, they're happy. So they basically train neural networks, feeding a lot of this input, and translate it into English. So they can put the application, listen to the baby, and the application says, hey, I'm happy, I'm happy, I'm happy. Or I'm hungry, I'm hungry. So it's not only for images, it's actually in this case working for audio. And my favorite one, if you think Superman is a hero, please fucking see this guy. So while you were doing corporate software, there was a person taking the time to take thousands of pictures of beers and training a model with TensorFlow for analyzing beer. So you don't need to wear a cape to be a hero. If you Google for something like recognizing beer, TensorFlow, you will get the model. The guy wrote an entire blog post saying how he made the training, how he fit the app, etc. And you can actually point with the application to any beer you have, and it will tell you exactly which beer you're drinking. So that's helping the world. Now, you have seen in this video that the translation was being on real time, right? That's one of the paradigms of why using cloud against mobile. If you're using the cloud, which is it's efficient, you would still need to send the image, compress it maybe on the device. That would mean a lot of traffic. Imagine the example with Google Translate. If each frame needs to be compressed, sent, you're probably it's not gonna be real time, it's gonna send a lot of data. So that's the idea of making it locally on the phone instead of on the server. And of course, we can use the motion sensors if we need this for our business case. So TensorFlow. TensorFlow is an open source library for machine learning. Here is the address, and today is the most popular machine learning framework in the world. There are actually two solutions. One is the TensorFlow Mobile and the TensorFlow Lite. The TensorFlow Lite is a solution that is very lightweight. It has a version for Android and for iPhone. It has a few problems yet. It's not ready for production. So actually in the documentation from TensorFlow, they recommend you to not use it on production. It has a smaller binary size, fewer dependencies. It has actually a better performance. And another problem it has is that it has a limited set of operators. So a trained model for TensorFlow Mobile might not fully work on TensorFlow Lite. Still, this changes every day. There are like a lot of commits into the TensorFlow repository. So what I'm telling you now, maybe in 2 months will change. And it's definitely happening very often. What you can do with TensorFlow is training models on Macintosh or Windows, on a GPU server, or on the cloud. And you have prediction frameworks for Android, iOS, and Raspberry. Yes, there is people using Raspberry. This is a benchmark called CFAR10. It has 10 models that get trained. For me, the interesting part here is that here we have 16 CPU. It takes 4 hours, 4.8 hours. And 1 GPU is 4.7 hours. That's for me the significant hop between using a GPU and using a standard CPU. So this is the proof that GPUs are good for more things than mining Bitcoin. You can also use them for training models with TensorFlow. According to TensorFlow, those are the companies that are using TensorFlow in production. Google, obviously, DeepMind, I think it was IBM or Intel, Twitter, etc. Now I want to show you a particular use case, and it has been this guy here on Twitter, Yufeng. He's a developer advocate for machine learning at Google, and he created this model on how you can move from an idea into actually training the model and deploying the model. So first, we have a series of stages here. We need to gather training data for training our model. Let's think of video. How would you gather a lot of data if you want to train your model? Do you have any idea or any first thought? How would you collect the pictures to get a lot of them? Google would be an option. Private pictures. Excuse me? Yeah, that would be another option. You could get a good set from pictures. There is one that is faster and easier. Just taking a video. A video is the 1 frame every, depending if we're using PAL or another system, but every second we get 26 frames, right? So let's imagine we want to train a model for a beer can or an energy drink can. We could just take a video with different light conditions in different backgrounds, and we will have every 10 seconds 260 different new images. Well, there is actually training a model right now. It's generally the core or your business intelligence. To have a good model, you need a very high quality set of data. So this is okay for this example. If your company is developing models, this is probably not enough. You want to do many different things. I found reading Twitter recently a funny example. And it was just to show you how training this model is very important. There was a company in California that was training some models to find if they wanted to see, okay, we will show some pictures to the users, and we will qualify some pictures and say if this is a good place or a good destination for holidays or not. So they have millions of pictures with a beach or people in a suit at a company talking about something. And on a first try, they externalized this to Southeast Asia, to Vietnam and Thailand. And they found that everybody in Vietnam and Thailand was clicking on the pictures with people with a suit and like this in a conference saying like, this is good, this is good, this is good. Why? Because these people live in a paradise, tropical paradise, right? So for them the beach is nothing exciting, but having these nice clothes for them means that, yeah, those guys have money, they can go to a really nice hotel. Whereas in California, if you're having this suit with very nice clothes, it's like, fuck, I want to run away from here. This is not interesting anymore. So see that it really, the power of having this business intelligence is super important today. So yeah, we will have our set of data. Now we can use a tool like FFmpeg to get all the frames, put it in a folder. Now there is this very interesting cloud machine learning engine. You can train obviously the models locally, But you might want to try them into the Google Cloud option. So if you have Google Cloud storage, you can upload them here. In Google Cloud Machine Learning, say, OK, go to this bucket, take all these images I have or all these files, and create my model. You pay Google whatever, and they take care of doing that for you. Now, I want to show you how, very shortly, how a convolutional neural network works. Those are the neural networks used by TensorFlow, just so you understand them conceptually. Do you know this author, this painter? It's called Hescher. I don't know if the name sounds German, so probably German or Austrian. And he made these impossible patterns, like here we have like people all the time going up, or people that pretend to go down and never go down, etc. He plays a little bit with those perspectives. Imagine you have this puzzle. How would you solve it as a human? So a machine, a neural network doesn't work that differently than a human. We will probably first want to make a separation between patterns. Like, let's gonna take the white ones and the ones that have some shapes. That would be the first approach. In this case, it's harder because it has only 2 colors, but if we would have a puzzle with more colors, we will separate them maybe by green, by brown. Now, when we have the colors separated, we will try to find some patterns. Here, for example, we see that here we have like some kind of shape, and here a different one. You can see that they're a little bit different. So we can start constructing this first, right? Let's gonna try to see this pattern, and we start making the puzzles smaller. And then later we see that we have some lines, and the lines can be perpendicular, the stairs. So there are probably some pieces that we can start combining, or at least taking them together, until we put some stuff like this. And yeah, that example is particularly hard, but this is how a human would work, right? By trying to find patterns, grouping them together, and creating the final solution. Well, that's exactly how a neural network works. This is an example of a neural network. It has 48 levels, and you will ask yourself, is this a lot or not? Because I ask myself the same question. I don't know if this is too little or not. Just to give some perspective, each level of the neural networks adds an exponential layer of accuracy. And 4 years ago, neural networks had 8 or 9 levels. So it has exponentially increased in 3-4 years. So yeah, let's see how a model works. When we create a model, the model resulting from TensorFlow is around 80 megabytes. This is a lot for a mobile phone, right? Because you cannot say, okay, your application it's 30, whatever. Per model is 80 extra megabytes. Well, there is a process on optimization called quantization. It basically means that those models are files with float numbers. They have no more secret. Of 32 bits. So you can cut them from 32 into 8. That's by dividing them by 4. And they don't lose that much accuracy because the neural networks are very resilient for fuzzy input. So they will lose, on average, 2-3% of accuracy. And you're cutting by 4 the size of the model. So that's a really good solution for mobile devices. And the process is quantization. When that's done actually with the neural network version 4 from TensorFlow. There are another ones, like the version 1. When the model is quantized, it's only 7 megabytes. So that's something you could consider. If it's still this 20 megabytes a lot, you could use the first version of the Inception network. Now, more things considered in the APK size. TensorFlow increases the APK in 12 megabytes in the case of Android. So that's something you also need to consider for your mobile app. So now it has been optimized in this step. Now we need to load it into an Android app. We have 2 approaches here. One would be to deliver the app with a model inside in a single APK. So the final APK will have all the models included. That can get maybe a little bit big, right? If we have a few models. Or we can deliver them separately. People that was advocating for this model, they said, this is more secure because everything is inside the same APK. But You know, if you have a root device or an emulator, you can take the APK out and basically extract everything you have in. Even if it's with ProWare, it takes you approximately 20 minutes to do it. So that's probably the best approach now. You can upload the models into Google Cloud or Firebase and download them as you need. And this also has the advantage that if you need to update the model, you don't need to download the entire app. You just send the model that has been updated and you're saving a lot in traffic. So a little bit more about the community. It has more than 1,000 contributors, 22,000 commits, 18,000 repositories with the name TensorFlow. I like from time to time to go to GitHub, search for TensorFlow repository, filter by new or new popular, and you realize that people is a little bit crazy. They are starting to create these very interesting repositories and ideas. This is how it has been growing the interest over time. So as you see, TensorFlow and machine learning now are deeply connected, and it's now an important part on the entire machine learning. So now I'll try to go a little bit over how to particularly use this on Android Studio and iPhone. So in the case of Android Studio, it's not very straightforward to install it. How many people here are Android developers? Okay, most of you. Out of curiosity, iPhone developers? Okay, I see some merged profiles, right? People developing for both. How many of you know Bazel as a building tool? Okay. Like it? No, me neither. Yeah, so I don't know why some person at Google decided, it could be a very good idea to use Bazel to build to build TensorFlow for Android. Yeah, so we need to use Bazel. In order to do that, we need to set the location in this path from here, add the project to Android Studio. You need to install Bazel first, downloading it from one of the repositories here. Install instructions. To point out to the install instructions takes 10 seconds. To actually follow the install instructions might take you 2-3 hours. You need to download the Android Studio SDK 23, the Android NDK 12b. It's recommended to do it with Android Manager. If not, it breaks very often. You need to update your workspace file and change the path where you have the SDK and the path where you have the NDK. So as you can see, it's still very manual. You need to run Bazel. Normally when I run it here, I get like errors during 1 hour of this dependency is not installed, please install. Then you install the dependency and get an error because a dependency of the dependency is not installed. It's a long story. Then you need to install the APK and it's done. Or you could download it from G-Center or Maven. But could you say this is the right option, right? I'll just put it into the build Gradle. The problem is that right now, the conversion is less efficient from YUV to RGB, and the object tracking is not yet available. This might change at some point, but that's unfortunately how it is right now. Android gives us 3 examples, one to classify, another one to detect, and another one to stylize. The first one to classify uses Google Inception version 3 to label images. The models are very easy to swap. We just have on our Gradle file the name of the model, so if you have your own one, just change it. There is no label for person, and if you press the volume knob in the phone, you get some statistics. This is how it would work. Here we see that we have some apples, and it says that with a degree of confidence of 0.98, those are Granny Smith apples. And it's cool because it's this efficient. It doesn't say like those are apples or those are fruits. It's a fucking Granny Smith apple. So it can get really, really deep. This is an example I took with an old phone on a lonely night. And as you can see here, it's saying this is a wallet. On here, this is an iPod. Here it fails a little bit. It was actually an old phone. Here it's not super clear, but says something like Macintosh keyboard, laptop, keyboard, computer keyboard, and it's switching on real time. Here it tells me this is a bottle of water, plastic bottle. And the models actually are so cool because you can actually pack them together, deliver them, and they're as efficient as to be like on real-time switching between all the objects that have been trained for. The model to the demo for detecting is used to draw boxes around people, only people in this case, and is useful to count objects. So if you have many objects on the picture, you can just put a model and it will start telling you how many of those objects are present per frame. No training supported yet, might change in the future. And the last one from Android is the styling demo. It picks real-time style transfer algorithms. You can pick some of them or mix them. And I don't know if you know Magenta. Magenta is a framework from Google to create music and create art with a computer, to generate it programmatically. And there was an interesting experiment. Using Magenta, some researchers create some jazz music or classical music, sorry. And they show it to people that had no musical training, together with some real music from Mozart or Schopenhauer or whoever. And non-professional people were not able to find the difference between Magenta-generated content and professional musicians, which is called Terminator. So in this case, the phone is very small. This is a Samsung S3, I think. It's very slow. But I could choose some models from Magenta, combine them, and it's actually done in real time. It combines on the resulting picture, applies the model, and yeah, you can like apply any different artistic models from Magenta. Now, TensorFlow is written in C++, Android uses Kotlin or Java. How do we do it? Very easy. If you use Android, you probably know the GNI or the native code. There is something called Android Inference Library, a little bit different from GNI, but based on GNI, and can talk directly with TensorFlow. Now, iOS, it works a little bit easier. You need Xcode 8, the command line tools that you probably already have if you have iOS. Brew install automake, brew install libtool. You need to run this script for 20 minutes, and you generate all the different demos. The simple one loads a model and gives information about it. Nothing special here. The one of the camera is the same as in Android. Here in this model, it tells us which degree of confidence we have, which breed of cat it's here. Like it's a tabby cat or a lynx cat or whatever. It runs Impsension on each frame, and you can also replace the models very easily. And then we have a benchmarking that loads a model and starts telling you benchmark information about all the whatever, how the neural network is actually running, the efficiency it's having, the processes are running behind it, etc. So it's very interesting to learn. Now, Raspberry Pi. I don't know your story with Raspberry Pi. My love story with Raspberry Pi consists in buying one 4 years ago and leaving it on a box, and it's still there. But some people really use this Raspberry Pi, and they create a lot of experiments around it. And there was, in Japan, you know, if you look for strange things, in Japan there are many. There was a person that owned a cucumber factory. You know, like they had some factories, they were growing cucumbers, delivering them to supermarkets, the process that whatever is happening there. And this person thought, we could probably train a model with TensorFlow to differentiate different types of cucumbers, because cucumbers can be green, can be mature, can be long, can be short, and maybe I could automate this entire process. The people working at the factory probably were not very happy about this, but the guy decided to move doing this. So he got his Raspberry, compiled the model, put some machines around. He wrote a blog post in Japanese about this that, well, you can Google Translate, and he pretty much claims that this is working like slow, because you know you need to move them like this, but it's essentially as accurate as a human. So he said that with more resources, I could buy something that moves the things really fast and is taking a picture with TensorFlow. It tells me which kind of cucumber it is, and moves it into the proper box. So yeah, that's fantastic. I don't know if it's something useful for you at home to classify your own oranges or apples, but I don't know, for this guy it was working out. So there is also an SDK for Raspberry Pi that you can download, use, compile your models, and it will work as for Android and iPhone. Now, some people ask me, so that's cool, how that's combined with Core ML. TensorFlow has an API for iOS, so you could decide, well, I could use TensorFlow and compile natively or use it natively in iOS and Android. But you can actually export to CoreML as well. There is, since the latest version of TensorFlow, there is a transformation tool that takes the model, makes whatever transformation makes, and works directly on CoreML. So that's something that you can, in principle, reuse. It doesn't work the other way around, as far as I know, compiling from CoreML into TensorFlow, but that's always a decision you need to take based on the business you have. So yeah, some final resources, TensorFlow, you can just Google it and find it. Magenta is this very interesting framework. If you have any interest about art or computer-generated art, that's very cool to watch and read. You can spend a lot of time researching, and there is like really crazy people doing crazy things. And if you want to move a little bit more into the really technical part of TensorFlow, you have this code lab from Google. It's called TensorFlow for Poets, and they teach you how to install it locally, how to train all the models, how to perform a few more operations, etc. So it takes like 4 or 5 hours, if I remember right. I think it's a very cool starting point if you want to get a little bit deeper into TensorFlow. So one of the last things, yeah. I would like some feedback from you. It always helps me a lot to know which parts are more interesting or provide more value. So if you go to this address, bit.ly mobile first UA, and give me your feedback, I'll send you a copy of one book I wrote about how to, with questions and answers to help you find a job as an Android developer or to find a candidate. I use it for both parts. And last but not least, the most important thing, I don't know if you know the Kotlin Weekly, but if you don't know it, I can give you stickers for your computer or for your phone. So just came to me later, and I have still a few. That was everything. Thanks for being a fantastic public, and I would love to answer any question, or you can grab me at any time as well. I'll be walking around for a little bit.
Okay, thank you so much. Let's say thank you. Who has a question? No question? Oh, okay. I'm going.
Hi, thanks for great speech. I want to ask, what tasks did you solve in production apps except recognition?
Can you repeat the question?
What tasks did you solve in production applications except recognition?
Well, I only solve the problem of recognition. So my experience in production with TensorFlow has been for a car, a self-driving car in Munich that is driving from the airport to the parking. It's like 5 kilometers, no risk because there is nothing else there. The car has 2 cameras on both sides and one at the top. And with those cameras, they are positioned to find, for example, signals, to find if there is like some obstacles, you can also find them, or to find if there is like some turn to the left or turn to the right. So it can at any point find if any of those things are happening. This is not the most efficient for all of them. For example, if it's cloudy or if it's raining, it will be very hard to find a signal. In the case of a self-driving car, the idea is not having one single point of failure. So it's actually the device is using, or the car is using radio to talk with some radio devices that are on the road, and the devices are sending information all the time, like, oh, in this coordinate there is a semaphore, or in this, for example, traffic lights you can find with them, or in this point there is a signal speed of 20 kilometers per hour, etc. But in the case the radio receiver gets broken, you need to send the car back to the parking, right, or to make it stop at some point. So this can be solved with TensorFlow, for example. In nice conditions, it can fairly find another cars on real time, find signals, find trees, or find any obstacle in the road.
Thanks.
You're welcome.
Anyone else?
As for the whole machine learning thing, it uses statistics and blah, 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 so it can predict something with some certainty, but never 100%, right? Can we expect any breakthroughs in this area in foreseeable future so that we could rely on that, like machine learning? Like if this iPhone says this is a wallet, this is 100%, this is a wallet, we can be sure.
Well, I think one clear example is the translation, for example. For the translation, basically how Google is feeding the networks, they keep the structure in the format they have, probably like this correspond to this, or this, I mean, that's simple. Maybe they have like a million of rows saying that this might be similar to this language, or this phrase might be similar to this other one. But the evolution of the translation systems is being amazing. Like, the ones between Romanic languages, like Italian, French, and Spanish, are now very close to 100%. So at some point it will hit, maybe not 100, but 99 point blah, blah, blah. And with this degree of accuracy, sometimes maybe you don't need a translator. Or for Chinese is still a little bit far away, but as soon as it gets into 99 point something, think of, like a lot of people is going to lose their jobs, right? So that's, it happens a little bit like with the self-driving cars. Like it's gonna take one entire sector of the economy and it's gonna break it. So, well, it has happened throughout all history, but I think now things are gonna accelerate a lot how they change. So in the more immediate future, self-driving cars is one of them. Translation is another one of them. And any kind of digital business where you need to deal with data. I was talking with a lady in Spain. She was doing some sentimental analyzer to actually track in Twitter for companies how to, if the opinion about a company was positive or negative. So basically this lady was training lots of data on if a sentence is it's supposed to be happy or sad or having a different degree of emotion about a topic. And the idea was offering a service to your company, like see how people are talking about you over a certain period of time. And she mentioned that the training was getting so accurate that it was even detecting sarcasm. Like if you say, I wish they keep doing this business until they make something terrible. That's maybe sarcasm in certain situation, and the neural network was detecting that as sarcasm, which is, some people cannot get sarcasm, you know, like my mother, if I say something sarcastic, she says like, oh, are you serious about this? No, it was ironic. So the machine can also get at some point better than humans.
And one more question is with you just touched the translation thing and speech not speech recognition, it's like the sarcasm. Okay. For the obvious reasons, we can Google cannot translate some politically incorrect speech or swearing, slang. Is it just because of like political reasons, for not to offend anyone, or it'll be harder for a machine to understand these things?
I'm not endorsed.
Could you in theory teach machine to recognize?
If it could be easier too.
How do you think, would it be much harder for a machine to learn to recognize not only like politically correct, grammatically correct speech, but slang or some swearings?
That's not, for a machine, it's not difficult at all. In fact, I don't know if maybe you heard of this experiment. I don't know if it was IBM, I think it was IBM, they released a Twitter bot that was learning from humans what they were writing or something like that. IBM or Google, I don't remember. And they had to deactivate the bot in Twitter, because after 5 or 6 days he was saying like women are terrible or black people are terrible or whatever, and they cut it down. So a bot or a machine learning system or an artificial intelligence system can learn absolutely anything. Now, what you say, there is censorship as well in all those things. Sometimes I believe it might be with a nice intention, like in this case. So you obviously a bot cannot start saying that it's going to kill everybody that is a minority in the world. In some other cases, might be not that well-intentioned, like well, you know, big organisms. They obviously have their own agenda, and an example is how, well, you know, companies that are operating in China, they cut a lot of censorship required by the Chinese government. Like, please don't talk about Tiananmen Square or all those things. I think in that sense, probably the obstacle is more the human rather than the machine. The machine just, with the current techniques, gets feedback, generates output.
Okay, thank you.
You're welcome.
Okay, it seems like no more question. Let's say thank you again.
Thank you, too.